So I'm going to change gears a bit and talk about spatially resolved polarization observations. And this time I'm going to talk about optical polarization in the kiloparsec scale jet of 3C273. And this is work that I've done together with Kari Nilsson from FINCA. And I will say up front that the image I'm going to present that we've taken with the Nordic Optical Telescope has been fully reduced and analyzed by Kari. So I should really thank him for that. And that's his major contribution. But to start with the one slide of motivation of why we're interested in this kiloparsec scale polarization of these sources is that we know that many of these sources have these jets that extend outside the host galaxy itself. But it is still unclear what keeps these jets collimated all the way to these kiloparsec scales, and magnetic fields are thought to play a major role in it. So then it makes sense to study the polarization structure of these kiloparsec scale jets. And why 3C273? Well, it actually has a very prominent kiloparsec scale jet, which is visible from radio all the way to X-ray wavelengths. So here's an example from a fairly recent paper by Marchenko et al., which studied the alignment of the jet at different wavelengths, and the top panel is the Chandra X-ray image, and then there is a UV image from HST Hubble, and then the bottom panel is the VLA. And what's evident from these radio to X-ray images, and it's actually a different part of the jet that's the most prominent at different wavelengths, which is interesting as well. And there are indications that the polarization is at these different frequencies, even in 3C273, are not always consistent, and it's not fully understood why that is. So there have obviously been also previous optical polarization observations of 3C273. And here are two early examples, one a ground-based experiment where the data were taken in 1987, and with a fairly non-optimal seeing conditions of 1.6 arc seconds. So here's the kiloparsec scale jet. It's about 22 arc seconds in length. And in this ground-based image, I should also note that here what is plotted as vectors is the magnetic field direction. So it is shown that the magnetic field is aligned with the jet direction up until to the hotspot at the very end of the jet, where it flips by 90 degrees. And then on the right-hand side, what I'm showing is an early HST image, a polarization image before the aberration correction was done. But still, it shows almost a similar structure with magnetic field aligned with the jet direction, but then towards the hotspot with a much better angular resolution, it's possible to see these wiggles in the jet, and then it's not so clear whether these are consistent or not. And in fact, Jester et al. 2007, who studied a lot of the emission mechanisms in the kiloparsec scale of 3C273, actually concluded that these are not exactly consistent with each other, mainly because of the flip seen here in the ground-based image. So there was a call for sort of new images of the source in order to verify whether this is actually a discrepancy between the ground-based and HST observations. So we then decided to look at it again with a ground-based instrument. We observed the source with the Nordic Optical Telescope with the ALPHASC instrument in 2019 for 3 hours. The seeing was 0.6 arc seconds, so much better, but we have done some, or Kari has done some binning to the image. So each of the pixel here is 0.4 arc seconds. Our resolution is still around an arc second in this case. So the color scale I'm showing is the total intensity, and the vectors are now showing the electric vector position angle. So EVPA instead of the magnetic field. So it's 90 degrees different to that one. And I should also mention this is a very preliminary image. But again, we see that if you now take into account the 90-degree flip, we see that the magnetic field in the jet is aligned with the jet direction, but then there is a flip in the polarization here towards the hotspot, which we also see. But there's also been a new HST image that has been taken from the source. This is by Eric Perlman's group, who are working on full analysis of this image. And I would say that the main features that can be seen in this HST image, where the color scale is now the total intensity, and then the vectors indicate the polarization in a way that the length of the vector is proportional to the fractional polarization, and the direction shows the direction of the electric vector position angle. It also shows that, it shows that the polarization is mainly seen at the jet edges instead of at the center of the jet. But if we do a crude comparison by eye to this, our very much poorer angular resolution image to the new HSD image, we can see that it's broadly consistent. So here, the EVPAs are in the same direction. So the magnetic field is aligned along the jet direction. Same within this region here, which corresponds approximately to what we see here. But then when we come to the hotspot region, it's not exactly clear what's going on, because what we see here is the sort of the entire end of the jet with a flipped polarization, while in the HSD image, it's visible that in the center of the jet, the EVPAs are aligned with the jet direction as we see, but then towards the edge, southern edge, they flip around. It's more radial from direction of the hotspot. So our current very preliminary interpretation here is that because our knot observations are not very sensitive, that maybe we're not really seeing the full jet. And here's another indication why that could be happening from radio. So these are 15 gigahertz images taken with the VLA from Perley et al. At 2 different angular resolutions. The left-hand side is at a higher angular resolution, which is more sensitive. And what can be seen in this plot is that the EVPAs in the center of the jet are aligned with the jet direction, but at the edges, they are perpendicular to it. But then if you go to higher angular resolution, which has poorer sensitivity, what happens is that you lose the sensitivity at the jet edges, and then only the center part is seen where the magnetic field is parallel to the jet direction. And it's a bit unclear at this point what exactly we are seeing in the optical, and I think we would have to do more alignment, but this is a preliminary image. And just to give you a very short sneak peek on what we've also done is to take images of the hotspot region of 3C273 with ALMA. So here's a very
3 more minutes, Talviki.
Thank you. Very preliminary image of at 345 gigahertz, and very preliminary. It only includes half the data at the moment. So we're gonna hopefully improve the sensitivity of this image by quite a bit. But the color scale is the polarized flux, and I just wanted to show that the EVPA vectors, which are barely visible as they're white, it agrees extremely well with the 15 gigahertz image here. But hopefully we'll gain some more sensitivity when we process the data a little bit more. So that's just a little motivation. And since my time is up, I'm just going to leave my conclusions here. Thank you.